And today I'm going to be going over how to draw bond line drawings. So bond line drawings are going to be one of the first things you'll learn in Ochem. So let's just go ahead and jump right into an example. Let's say we have C3H8. So how can we show this Lewis structure as a bond line drawing? So there are several rules that go into bond line drawings, and one of the first ones you'll learn is carbon chains, so carbons in a chain, are drawn as zigzags. Okay, so let's just go ahead and draw this Lewis structure as bond line. So this would look like this. So if you notice, each carbon is a point on the zigzag. So this carbon would be this point, and lastly, this carbon would be this point. Now you might be wondering where the hydrogens are, right? Well, so why didn't we draw the hydrogens? Because this is actually the finished product. So a second rule you'll learn is that whenever hydrogens are just attached to carbons, you don't have to show them because they're implied. You can though, so I can go ahead and draw those in. And so that's what it would look like with the hydrogens, but generally you don't have to draw them because they are implied. Okay, so let's go ahead and move on to another example. So when I was talking about not showing hydrogens when they're attached to carbon, what happens if they're not attached to carbon, right? What happens if they're attached to oxygen or nitrogen, for example? So in that case, if a hydrogen is attached to a heteroatom, or an atom that's not carbon, then you have to show the hydrogens. So once again, if there are hydrogens attached to non-carbons, they must be drawn. So for example, let's say we have this bond line drawing. And you can either show this as this, or you can also show it as a bond to the hydrogen. Okay, so if you notice, we didn't draw the hydrogens here, but we drew them attached to oxygen. And so that's pretty much it. If hydrogens are attached to oxygen, nitrogen, any other atom that's not carbon, you do have to show them, but you don't have to show the ones that are attached to carbon. Okay, so how do we show double bonds and triple bonds, right? So for double bonds, all you really have to do is draw a singular line perpendicular to whichever line you're trying to attach a double bond to. So you can do it like that, you can do it like that. It really doesn't matter exactly where you put it or whether it's up or down. This is just how you show a double bond. So if I were to draw the Lewis structure of, say, this, right? It would be C, C, double bond, C, and then all the different hydrogens. So hydrogen, hydrogen, etc. Okay, so let's go over some good and bad things that you want to look for and notice and be able to recognize when you're drawing bond line drawings. So first off, when you're drawing bond line drawings, when you're drawing bond line drawings, you want to draw them with 120-degree angles. So let's say we have this one, right? And let's say there's a double bond here. These angles are good. It shows that it basically shows like the proper alignment and how they would actually look in a 3D kind of space. So this would be a bad way of drawing this. So say we had like this. You don't want to draw it like this. This angle is too acute, and we really want to show these 120-degree angles. Another thing, we don't want to see 5 bonds in a bond line drawing. So for example, we don't want to see something like this. So if you notice, this carbon actually has 5 bonds, and carbon can't have 5 bonds. So this is actually a wrong bond line drawing. This wouldn't even exist, because this has 1, 2, 3, 4, 5 bonds. So always be sure to count your bonds, and eventually with enough practice you'll just be able to recognize when something has 5 bonds. Okay, so I talked about double bonds, but I didn't talk about triple bonds. So how can we show triple bonds as a bond line drawing? So let's say we have this molecule. So how can we show this as a bond line? So when you're drawing triple bonds, you want to draw a linear line for the carbons. You don't want to have a zigzag. So what do I mean by that? So let's go ahead and draw the line. And for triple bonds, it would just be a bond on top and a bond below. So let's go ahead and show the different carbons that are on here. So this carbon here is this point. This carbon here is this point. This one, this point. And lastly, this carbon is this point. So, and we don't have to draw the hydrogens because again, they're implied. So if you notice, this structure represents 4 carbons. So that final rule is triple bonds must be drawn linearly. They can't be drawn at an angle. So what do I mean by that? Well, something that would be a wrong way of drawing this would be, for example, like this. Oopsies. So we don't want to draw it like this. We don't want to show these zigzag points. This would be wrong. But what if we have something with more than 4 carbons? So say, like instead of a hydrogen, we had another carbon, right? So let's say we have another carbon, or a CH3 group, let's say. So how can we show that? Well, this part here is still going to be drawn linearly. That triple bond there is still going to be drawn linearly, but this carbon can be shown with a little bit of zig or zag to it. So we can show it as this. And so this carbon here is this, and this carbon on this side is this. So just the section that is connected to those carbons with the triple bond, just that section has to be drawn linearly. Okay, so let's go ahead and summarize all the different rules we learned. So first, carbons should be drawn as zigzags. Second, draw all non-carbons and hydrogens attached to them in your bond line drawing. Third, make sure you have 120-degree angles for double bonds. 4, don't exceed carbon's octet. You never want to see 5 bonds on a carbon. And 5, draw your triple bonds linearly. Alright, that's pretty much it for the video. Thank you guys so much. If you like this content, please like and subscribe. And see you next time.